The figure above shows part of the curve C with the equation y equals x minus 1 times x squared minus 4. The curve cuts the x-axis at the points P and Q as shown in the figure above. We need to write down the x-coordinates of P and Q. Well, at P and Q, I can see that the y-coordinates are 0. So if I take my equation here and make that equal to 0, I can see that that means that either the x minus 1 is going to equal 0, which gives us the solution of 1, which we already knew here, or it could be that the x squared minus 4 equals 0, which means that x squared would have to equal 4, and so x would have to equal 2, or minus 2. So therefore we've found that point Q is when x is 2, and point P is when x is minus 2. Right, moving on to part B. We need to show that dy by dx is 3x squared minus 2x minus 4. So I need to differentiate this. Well, I can't differentiate it the way it's written at the moment. I need to expand those brackets. So let's do that. The x times the x squared is x cubed. The x times the minus 4 is minus 4x. Then we have the minus 1 times the x squared is minus x squared. And the minus 1 times the minus 4 is plus 4. And then I'm just going to rewrite that in descending powers of x. So I've got the x cubed at the front, then the x squared, then the minus 4x, then the 4. And now we're going to differentiate that. So the x cubed will differentiate to be 3x squared. The x squared will differentiate to be 2x. And the minus 4x will differentiate to be minus 4. And the 4 on the end there, because it's a constant, will differentiate to be 0. So that is my gradient function. Part C says to show that y equals x plus 7 is an equation of the tangent to C at the point minus 1, 6. So I need to show that at the point minus 1, 6, which is roughly over here somewhere, the tangent at that point has got the equation y equals x plus 7. That's what the question's asking me to do. So the tangent is a straight line, so y equals mx plus c. And I know that the tangent has the same gradient as the curve. So therefore, to work out the gradient of the curve, I can take the x-coordinate and substitute that into my gradient function. So I would get minus 3 times minus 1 squared minus 2 times minus 1 minus 4, which gives me a gradient of 1. So the gradient of my curve when x is minus 1 is 1. Therefore, the gradient of my tangent at that point is also 1. So I can say y equals 1x plus c, or I could just say y equals x plus c. To work out the c, substitute the coordinate in. So y is 6 when x is minus 1. Add the 1 to both sides. And I find that y equals 1x plus c plus 7. And so therefore, the equation of the tangent is, in fact, y equals x plus 7, which is what we needed to show. Then we are told that the tangent to C at the point minus 1, 6, so what we just found, cuts the curve again at point R. So you can't really see that it's on my diagram the way it's been drawn there, but C would keep going up here, and eventually R and C would intersect. My straight line here and the curve there would intersect again. So we need to work out that coordinate. So it's simultaneous equations working out where these two lines are going to intersect. So let's do simultaneous equations with the cubic for c, which is the x cubed minus 4x minus x squared with the x minus 7. So we will have x cubed minus x squared minus 4x plus 4 is equal to x plus 7. Take the x away from both sides and take the 7 away from both sides. We get this cubic equation. We can solve this cubic equation now. We already know that minus 1 is a solution to both of these. The curve and the straight line intersect at x equals minus 1. Therefore, x plus 1 is a factor of this cubic. I just need to work out the other factor. So, quick bit of algebraic division here. So the x goes into the x cubed x squared times. The x squared times x is x squared. The x squared times 1 is x squared. And we'll take that away. X cubed take away x cubed is 0. The minus x squared take away x squared is minus 2x squared. And then we'll repeat the process. The x into the minus 2x squared goes minus 2x times. Minus 2x times x is minus 2x squared. Minus 2x times 1 is minus 2x. And we'll take that away. The minus 2x squared take away the minus 2x squared is 0. The minus 5x minus minus 2x is minus 3x. And then the last time, the x into the minus 3x goes minus 3 times. And so we have the other factor now, the x squared minus 2x minus 3. Now we can completely factorize this cubic. To get x plus 1 times x minus 3. So our solutions are minus 1, which is a repeated root, which makes sense because it was a tangent at that point, or x equals 3. I just need to know the y coordinate now, so if I substitute 3 into either of those original equations, I find that the y coordinate of point R is 10.